Hi, my name is Caleb Mossy. This is the second submission for the Mobile Robotics and Manipulators module of Middlesex University's Robotics Bachelor's degree. We've been tasked with using ABB Robot Studio, as you can see here in my virtual machine. It's running to show varying levels of complex programs, to show that we know how to program in rapid programming language, ABB rapid programming language, using Robot Studio and showing a strong understanding of transform frames, coordinate frames, tool coordinate frames, and other robotics topics. So to start, this is the virtual machine running my program. So I have generated 3 programs for the user to interact with. The first one, pretty simple. I manually jogged the robot around the work object here and defined some points to draw my initials on the table. So in order to show the drawing, I'll turn on the TCP trace, and I will just set a primary color, turn that off for now. So provided I've set everything correctly, ready for this, I should be able to click draw initials, and the robot will indeed draw my initials, Caleb Jake Mossy, on the table. Now, the work object and the table aren't particularly directly linked. I can move the work object, and the table is really there for a visual understanding of the workspace. And I'll show that after. But I just wanted to explain that to say, you can see here, the drawing isn't actually on the table. That's because I've defined the work object as a couple of millimeters off of the table. So in the scenario where this was actually holding a pen, we wouldn't be slamming into the paper and possibly ripping it to pieces. As that's what this is supposed to simulate, is a robot drawing. So I've gone for an art-themed submission with the other 2 programs, both drawing. Well, the next one I'll show is drawing a Da Vinci, the Mona Lisa. On the other page you may have seen, well, not quite yet here, I made an SVG of the Mona Lisa based on another SVG I saw. I cleaned it up and into a SVG that I could use in Adobe Illustrator, and turned that into a 3D model in the robots in Fusion 360, and then imported it into the Robot Studio here. So I can show you this if I hide this, and I clear the traces here. This is the 3D model I made, and this allowed me to trace the edges without having to manually jog each point. So using a tool in ABB Robot Studio here, on the Home tab, there's an auto path, and you can kind of select and it will generate paths for you, which is a lot quicker. So this is quite a complex drawing, so there are tons of paths and targets made. I've labeled them so they're easier to understand, but each of them consists of a ton of paths. For example, if I can find one of the more complex ones here, it's got about 1,000 points on it, where the robot needs to move to. Now, I have added some extra features to the simulation in that, in order to simulate kind of interacting with external hardware, if we were in a physical setting here, not simulating all of this, we'd be able to hook the robot or the flex pendant up to external hardware, so that we can communicate with other things. And in order to do that, we use signals. And so I can show you the program for the sections of the Mona Lisa we're going to draw. It's doing several things. So we have a draw on signal, which represents whether the signal is high or low, basically if we're drawing or we're not drawing. And this is used, I've linked it to the TCP trace, so that as the robot moves towards the page, it does not draw that line. That's because it can get quite messy and difficult to understand, but it will draw when it's actually on the surface of the work surface. So here we've got a move L do, and this is basically, it sets a digital output halfway through the end of the last curve of this movement. So it sets it high, which means we are on the surface of the work surface of the work object. We're drawing all of this stuff, and then at the end of this movement, we're going to stop drawing. We're going to turn off the TCP trace. We're going to wait for that to happen, because the robot moves at a much different speed, slower speed to the way the program runs. So that can often be quite visible in the TCP trace tool. Obviously, this isn't particularly useful other than for our visual representation of this task, but obviously it's important to make sure that our program and our robot are synchronized in any application. So waiting to make sure that this signal has been set properly is quite important. Now I do that for each part of the Mona Lisa. So I can show that in application now. I will go to the simulation tab, choose the TCP trace. So I'll enable it, but I don't want to use a primary color. And what I want to do is actually make sure that we're coloring by signal. Again, I've set another signal. I'll show you the other one in shortly. Just making sure I'm selecting by this draw on signal and coloring by that, and then only coloring when the signal is high. So as I click play and I click Draw Da Vinci, we can see the robot's end effector moves towards and away these points on the work object, but stops drawing. And the corners, without the wait operation to ensure that the signals have been set, you often find that the first and last point do not close properly, so they're left a bit empty. So whilst waiting, we're ensuring that we have successfully closed the path. Effectively, in this simulation here, the TCP has closed the path, we've turned off the draw signal, and then we've moved away so that we don't show the other lines. Now I can show you what this would look like if I didn't do that. You have these tools, you have these lines, and let me turn this off, showing where the robot moves away from the object and moves into it. So I'm going to stop that, reset, and I'm going to move on to the kind of final level of complexity I've created for this program, and that is the Piet Mondrian inspired piece of art. I'm sure it offends some people, but basically thinking about kind of an interesting way to show my understanding of this program, I thought about generative art, computer generated art, and one of the ones that came into my head was the Piet Mondrian, where basically initially it's not computer generated, but it's used quite often to gain a better understanding of computer generated art in, for example, Python, tkinter, and these other sort of GUI tools used for Python or other languages, of course. I think C, P5, is written in C++, I think, which also is used quite often for or computer-generated art. So this is a Piet Mondrian. It consists of squares of different heights and shapes, and it's kind of focusing on tension and creating tension in a piece of art. But it's quite a useful, a cool application for this task, I feel. So I based my algorithm off of this concept. Now, my algorithm is a little bit different in that it's not creating different squares within within the whole canvas, but it creates squares within squares within squares, almost like a the spiral in the background, actually. In that it will always choose the biggest square, slice that square again at a random point, and then create another square. And you'll see what I mean by it's like this spiral, because the squares randomly get smaller and smaller and smaller and meet at some point when it stops. So with the Piet Mondrian, it slices here, and then it slices again, and then it decides which one to keep. My algorithm doesn't do that. Mine will slice here, and then it will choose that this is the biggest square, and it will choose somewhere random to slice along this square as well. And it will choose not just where to slice it randomly, but also along which axis to slice it. So along the, in my world and the ABB Robot Studio, this is the x-axis, and this is the, to the left is the positive y-axis. So it can also slice along those. So in order to show that, there's also a couple of extra options the user can choose when you draw a Piet here. You can choose a depth, and that's how many squares within squares you want to draw. Now, before I do that, I'm actually going to change the TCP trace back to another signal, a square depth signal. And this is an analog output. Before it was a digital output, so just 0 or 1, and I was reading that value with the TCP tool here, TCP tracing tool. Whereas this one is an analog output. So I have set it to increase by 1 every time we get lower in the square generation. With every square we create basically in the algorithm. So I use a color scale from 0 to, let's say, 10, because 10 is the maximum amount of squares I've allowed a user to create here. Now, again, we'll still see these because I've changed the signal and I'm not telling it to turn off when it moves away. But I could do that like in the rapid end, but in terms of the TCP tool, it wouldn't be effective, because with this TCP tool, we can only select one signal. So I will run the program. It asks me my options again. I choose draw Piet. I can choose 0 to choose the default, which is 8, or I can choose another number below 10. And if I choose the wrong number, for example, -1, it will just tell me to ask again. And that's because it's nested within a while loop. So it's checking if I've chosen a valid answer, and if I haven't, it will keep asking me. So I'm just going to choose the default of 8 by selecting 0, and we have a robot configuration error. Perfect. Top left canvas, robot can't reach that, so we're going to move to this. We're going to check the configurations and try applying a different one. Synchronize that to rapid. Because so in this case, I'm actually going to choose auto configuration. Hopefully the robot will just find the best configurations. You've seen it move along the path there. I'll manually move along the path here. And what we're seeing here is the largest possible frame I've allowed the user to follow. So if I click play, Try this again. Fingers crossed. No, it hasn't worked. This is we can try moving to it with a joint movement. Synchronizing once more. So this is basically the robot saying, I can get there, but I don't know in which way to move my joints. There are multiple options here to move my joints to get into this configuration. So the TCP trace tool has gone a bit wild. It's lost which tool it should be following. I can change that just literally by clearing it. Now, let's see. Let's try drawing one for now. Ah, it's working. Wonderful. Except small bug here, because it is just going around in circles. Let's just play this again. I'm going to choose 0 for the default. There we go. I'm not sure what happened there, but it's randomly sliced the square here using a random number generator function. And it randomly chooses whether to slice horizontally or vertically. And you can see the color has changed as it's got deeper into the algorithm. So as one final thing, I can also move the work object to show you that moving the work object as possible, and the robot will just draw in a different position. Now I've actually saved some coordinates here that don't require too much fiddling of the joint configurations. As you just saw, I had to change a lot of the configurations for the Piet, and that often happens. Now this is saying the top right canvas is too far away. So I'm going to move this down a little bit more. And now it's checking if it can meet these configurations. Yes, it can. So I'm going to synchronize with rapid, but only synchronize the fact that I've moved the work object, because I don't want to confuse anything else. It says it's done. Now, if I click draw initials, it has indeed started drawing my initials within a different plane that is not orthogonal to the work object. Now it's frozen there because it can't reach the a certain point in the program, which is looking like this initial M. Again, the top one of those ones. So if I was to maybe make, see, it's really struggling to meet the criteria to get to some points of the letter M there. So if I move this across, close that, synchronize again. Play. Hopefully it'll be able to reach the, fortunately the TCP trace lost where it should be. Hopefully it should reach the all the coordinates of the letter M now. Oh, I say that, we do unfortunately have these. So you can see it requires some fiddling to make sure the robot can meet all of the points of a new work object frame, but absolutely possible. And as soon as those requirements have been met, You can run your programs in many different orientations that are not orthogonal to the world plane. So thank you for viewing my submission. I'll see you soon. Cheers.